Hello दोस्तों, today we will discuss 13 questions, out of which 3 are matrix match type questions and other 10 are compressive type questions. Let's read the questions. Option A, evoloscopic constant. Evoloscopic constant goes to R. Evoloscopic constant goes to R, Kp. Van Hoff factor goes to I. Osmotic pressure goes to P, CRT. And the cryoscopic constant is equals to Q. Here is the answer is A का क्या हो जाएगा R, B का S, C का P, D का Q. ये हमारा आंसर हो जाएगा. Next question. Column 1 and column 2. Isotonic solution. Option A isotonic solution. Option B Raoult's law. Option C Henry law and Van Hoff law. So isotonic solution is goes to Q. Option B Raoult's law is goes to P, that is Pa equal to P naught A, and Henry law is goes to S, M equal to Kp, and Van Hoff law is goes to R, I equal to CRT. So next question. In column 1, there is a 2 mole of A equilibrium with A2. Option B NaCl solution, SeaCl2 solution and FeCl3 solution. Here we have to calculate the Van Hoff factor, that is number of particles. If 2 mole of A is if A2, then we also write this, that A is equal to I equal to 1 minus alpha by 2. Here NaCl fully dissociate into ions, that is Na plus and Cl minus. Na plus and Cl minus. So here the I factor will be 1 plus alpha, and CaCl2, here the ion will be formed calcium and calcium 2 calcium plus, calcium 2 plus and 2 Cl minus. So यहाँ पर ऑप्शन P I इक्वल टू 1 plus 2 अल्फा हो जाएगा. और FeCl3 यहाँ पर होगा Fe3 plus and 3Cl minus. 3Cl minus मतलब 1 plus 3 alpha. Here will be the answer. Here is the answer. Next move to another question, that is compressive type question. Read the following paragraph and answer the question given under the paragraph. Here let's read the relative lowering in vapor pressure, the elevation in boiling point and depression in freezing point and osmotic pressure are called colligative property. We need to understand the concept of colligative property because this depends only on number of solute particles and not on their nature. If solute molecule undergo dissociation or association colligative property, it increases or decreases respectively. Here option 1. Which aqueous solution has at least vapor pressure? Here is the concept we need to understand, that the solution with most particle will have the least vapor pressure. Here the question says that which aqueous solution that has the least vapor pressure. Least vapor pressure depends upon the most particle present. Here we have to calculate where the number of moles of particles are higher. Here we see in option A 1 mole of glucose. Here glucose does not dissociate. That's why there is no number of particles will be generated. Here same also for 1 mole of sucrose. This will not dissociate. Here 1 mole of NaCl when dissociate, it form Na plus and Cl minus. Here 1 mole of NaCl when dissociate, it will form 1 mole of Na plus and 1 mole of Cl minus. When 1 mole dissociate, it will form 2 ion, 2 particle, 2 number of particle. Here, in option D, when 1 mole of MgCl2 dissociate, it will form Mg2 plus, 1 mole of Mg2 plus and 2 Cl minus, 2 Cl minus. Here the number of particle will be 1 plus 2 equal to 3. Here we got the answer. In option D, highest number of particle will be present. That's why option D will be the correct answer. Hope so we understand this question. Next move the another question. Which of the following 0.1 mole of aqueous solution has the highest boiling point? There is the basic concept to need to understand that the solution with the highest number of particles will have the greatest boiling point. Have the highest boiling point in question. There is asked that the highest boiling point. Have the highest boiling point depends upon the number of particles. Higher will be the number of particles, highest will be the boiling point. In option A, urea does not dissociate. That's why we does not consider this option. In LaCl, it will dissociate Na plus and Cl minus. So यहाँ पर 2 particle generate होते हैं after dissociate. In option C, there will be Ca2 plus, Ca2 plus and 2 Cl minus. 2 Cl minus, we have a 3 particle generator. 3 particle. In option D, FeCl3 dissociate, it form Fe3 plus and plus 3 Cl minus. Here 4 particle will be generated. 4 particle. Here the answer, that is option D will be the correct. Option D will be correct, that it dissociate, it form 4 number of particle. 4 number of particle. That's why option D will be the most correct answer. Next move to another question. What weight of solute is required to dissolve in 180 gram of water to reduce vapor pressure? 4/5 of pure water. Here we need to understand that what is given. Here the weight of solute. Let's discuss here. That here given is M2. That is the molar mass of the solute is 60 gram. 60 mole. And mass of the solute is 180 gram. And vapor pressure P is equal to 4/5 of P naught. Here P naught is the vapor pressure at air. The relative vapor pressure we have to calculate, that is del P by P naught is equal to 1 minus 4/5. Here we will discuss 1/5. The relative vapor pressure we calculate, that is 1/5 is the answer. In second step, we have to find the number of moles of solvent. Number of moles of solvent in N1 equal to weight of solvent and molar mass of the solvent. Weight of solvent given 180. Solvent, here solvent is water. 180 divided by 18, it is give 10 more. Give 10 more. In step 3, we have to have to calculate the lowering in vapor pressure formula, that is del P by P naught is equal to moles of solute divided by moles of solvent. Here del P by P naught, in case 1 we are derived that is answer given 1/5, and 2 we have to calculate, and in N1 value is 10. When it is has the answer, that is moles of the solute is 2 mole. In previous step, we calculate that number of moles of solute is 2. Here we can also calculate the mass of the solute. Number of mole of solute is equal to mass divided by molar mass. Mass of the solute divided by mass of the solute and molar mass of the solute. We have to calculate mass of the solute. So M2 is equal to N2 into M2. Here solute is who? Solute is solute's mole, that is 2, and molecular weight given in question, that is 60. Hence the mass of the solute is 120 gram. Here option C, that is 120 gram, is the correct answer. In question number 4, let's read the question. When 0.707 gram of solute is dissolved in 10 gram of acetone, here Kb is given 1.67 degree. The boiling point is elevated by 0.5 K. The molar mass of the solute is. Let's calculate. We know the relation, that is elevation in boiling point. Del Tb will be equal to Kb ebullioscopic constant dot molality. Here molality is equal to moles of solute present in mass of the solvent in kg. Mass of solvent in kg. Here del Tb, let's simplify this. We can write that moles of solute, mass of solute, and molar mass of the solute divided by mass of solvent in kg. Mass of solvent in kg. Here uh, del Tb, we can write in this equation that del Tb will be equal to Kp dot m. यहाँ पे आइए M2 डिवाइड बाय M2 मतलब मास ऑफ सॉल्यूट, मोलर मास ऑफ सॉल्यूट डिवाइड बाय मास ऑफ सॉल्वेंट इन kg. We can write let's remove this. Here we can write that del Tb will be equal to Kp, that is ebullioscopic constant, and M2 mass of the solute divided by molar mass of the solute and into mass of the solvent in kg. Mass of solvent in kg. Here we can simplify that molar mass of the solute is equal to Kp into mass of solute divided by mass of solvent into elevation in boiling point. Let's put the values of Kp. Here Kp value is given that 1.67 degree and mass of the solute is 0.707 and divided by mass of solvent is 10 ग्राम. ग्राम को अगर हम किलोग्राम में कन्वर्ट करेंगे तो 10 to power -3 हो जाएगा, इंटू 0.5. Elevation in boiling point given that 0.5. Let's 10 to power minus 3 ये पॉइंट कट जाएगा, देन ये 0 से ये पॉइंट कट जाएगा, फिर 5 से ये कटेगा, 5 1 ज़ा 5, 5 4 ज़ा 20, 5 1 ज़ा 5. ऑप्शन क्या है? Okay, let's evaluate this. That is molar mass of the solute. Molar mass of the solute is Kb, that is 1.67 into mass of the solute 0.707 divided by 10 ग्राम. 10 ग्राम को हम किलोग्राम में कन्वर्ट करेंगे 10 to power minus 3 into 0.5, that is elevation in boiling point. 0 से इसका पॉइंट कट जाएगा, फिर 10 to power minus 3 इसका पॉइंट कट जाएगा, फिर 5 से यहाँ पे कटेंगे तो 1.141.4. Here when we multiply 1.67 into 141.4 we get the answer, that is 236.138. Here the approx value we will consider, that is 236.1. Let's see the option. Let's see the option. Here the option 1, option A, that is the correct answer. Let's move to another question. What is the value of cryoscopic constant of water in K mole inverse kilogram? Let's calculate the question. In question 5, we have to know the relationship between the elevation in boiling point and has a freezing point is given. Freezing point. Cryoscopic constant means freezing point, that is Kf. Okay. So depression in freezing point and cryoscopic constant and molality. We have to know about the relationship. Let's solve the question. Let's solve the question, that is del Tf equal to cryoscopic constant, that is Kf, and molality. Here we have to calculate the cryoscopic constant, that is Kf. Here Kf is equal to depression in freezing point divided by molality. We have to know the relationship, another formula, that is R del T square divided by N2. Here we put the all formula, that is 1.987 calorie mole inverse and Kelvin inverse into 273.5 का whole square into 18.015 gram per mole divided by moles of solute. We convert the value, that is a calorie per mole. We have the value, that is 1441.2 calorie per mole. In simplification, in last we will get the value 1.86, and that is the correct answer. Let's check the option, that is option C. Here option C is present, 1.86. It will be the correct answer. Understand? Let's move to another question, that is the freezing point of aqueous solution of 5% urea and 10% glucose with W by W. That is the cryoscopic constant of water is given that 1.86 Kelvin mole inverse kg. here we here we have to calculate the number of moles of urea, then we have to calculate mass of urea, then its molality. Same case goes for glucose. We have to first calculate the moles of glucose, then mass of glucose, then molality of glucose. Then we will be add this molality value, and so let's see, let's solve the question. Let's solve the question. That is, here is given that molality of urea. We have to calculate molality of urea. First of all, the moles of urea is equal to 5 gram mass divided by molar mass, 60 mole divided by 1 by 12 mole. Then mass of urea. Then let's calculate molality. Is equal to moles of solute is 1 by 12 divided by, let's check the option. Let's read the question again. That is the freezing point of aqueous solution 5% urea and 10% glucose. Weight by weight. So molar mass of the urea will be, you have to first calculate molar mass. Mass of solvent. Mass of solvent, that is 100 minus 0. Minus 5 minus 5 minus 10. Here we get the answer, that is 0.085. Here we calculate the molality of the urea, that is moles of solute 1 by 12 divided by mass of solvent, that is water in kg, it is 0.085. In simplification, that is 1000 divided by 12.85. In simplification, we will get the answer, that is 0.98. Here we have that molality of urea is 0.98. So let's 0.98. Let's calculate molality of glucose. In molality of glucose, we have to calculate the moles of glucose. Moles of glucose, that is 10 grams, 10 divided by 180 divided by equal to 1 by 18. Here the solvent value, mass of solvent, that is M1 equal to 0.085, and molality of glucose equal to moles of solute 1 by 18 divided by mass of solvent in kg, that is 0.085. When we simplify this equation, we have the answer 0.65 gram mole per gram. Here the molality of glucose, you can find that 0.65. Let's add this equation. Let's add this equation, that is molality of urea and molality of glucose. Molality of urea, that is 0.98 plus molality of glucose 0.65 is equal to 1.63 mole per kg. del Tf, that is elevation in freezing point, equal to, we know that elevation in freezing point equal to cryoscopic constant into molality. Cryoscopic constant given as 1.86 into molality, here we found that is 1.63. Let's multiply this 1.86 into 1.63. We have the answer, that is 3.03 Kelvin. In question, it is says that the freezing point of the aqueous solution. फ्रीजिंग पॉइंट ऑफ एक्वा सोल्यूशन है, तो हम माइनस कर देंगे, दैट इज 2.273 माइनस 3.03 करने के बाद हमारा आंसर आएगा ऑप्शन ए, दैट इज ऑप्शन बी आंसर आएगा, दैट इज माइनस 3.04 डिग्री सेल्सियस. Let's read the another question, that is question number 7. The depression in freezing point of aqueous solution of urea, that is 0.4 degree Celsius. What will be the boiling point? What will be the boiling point of this solution? Here given that ebullioscopic constant and cryoscopic constant, that is 0.152 degree and 1.86 degree respectively. To solve this question, we need to first understand that the formula, the ebullioscopic constant, that is del Tb equal to elevation in boiling point equal to elevation in freezing point into ebullioscopic constant divided by cryoscopic constant. Here the values are given, we have to put and get the answer. And depression in freezing point value is given that 0.4 into ebullioscopic constant is 0.512 divided by cryoscopic constant 1.86. Point से point काटो, then 4 से 186 काटो, 4 4 जा 16, 4 6 जा 24, 4 5 जा 20. Here point will be present, that is when we calculate, we get the answer, that is 0.110. Let's check the option. Hence the boiling point of the aqueous solution is the boiling point of the aqueous solution. We have to calculate the boiling point of aqueous solution. Okay, boiling point of aqueous solution, that is boiling point of aqueous solution is 100 plus 0.11 equal to 100 plus 11 degree Celsius. Here option 1 will be the correct answer. Let's move to another question, that is question number 8. The freezing point of aqueous solution of an electrolyte whose osmotic pressure is pressure at 300 Kelvin is 2 atm is atmospheric pressure. Atm means atmospheric pressure. Here the let's calculate the value, that is concentration molarity equal to moles divided by volume of solution. Moles of solute molarity equal to moles of solute divided by volume of solution equal to pi divided by RT. Pi value is 2, R is universal gas constant. Its value 0.08212 into 300. In calculate this equation, we will be found that 0.0812 molarity m equal to small m equal to 0.0812. A depression in freezing point del Tf will be equal to Kfm. Kfm. Kf value 1.86, molality value 0.0812. In calculate this, we have the answer 0.151. Hence, the freezing point will be 0 minus 0.151 equal to minus 0.151 degree Celsius. Let's check the option. Here option D will be the correct answer. Let's move to another question, that is question number 9. For a dilute solution of K2SO4 in water, the Van't factor is, we have to calculate the Van't factor of K2SO4. K2SO4 when dissociate, K2SO4 when dissociate, it will give 2K plus plus SO4 minus. Here alpha equal to 2 molecules of alpha and 1 molecules of 2 molecules of K plus and 1 molecule of sulfate ion. We get the 3 particle of K plus and a sulfate ion. Here the answer will be 3. Option 3.